Welcome back, guys. This will be day 14 of me trying to learn TypeScript. Yeah, so it's still on generics level 4, and I might not even finish today this chapter, because it is going down for real. It is like going down for real. So yesterday I did generic constraints, which weren't really that difficult. We just have to use the extend keywords to say like it should at least have cost the object that we're passing. It should at least satisfy this type. Okay, so yeah, now we're doing type parameter for types. I did try and failed miserably yesterday, so I just ended up deleting the code. So I'm just gonna read today, yeah, and then try to submit the code. So I just finished studying. Actually, I studied and then napped, woke up. I'm doing this. I'm gonna do this and make sure I don't get tired. I'm gonna rest and continue studying. So this is that. Let's just continue. Type parameter for types. Type parameters aren't just limited to functions and method. You can use type parameters to create generic types as well. For example, this is an interface store. T is a type. Okay, this is a function. Get that. Okay, also works with type aliases using the. Okay, this syntax is not too. Okay, now a store can be anything that implements the methods above. But what is stored doesn't matter. We can create a function that uses the store, again not caring about what is stored inside it. Okay, finally we can create a store that specifically deals with product types. Say this is some type product, this is type S, so it should be okay. The S keyword is used, like, okay, it's interesting. They could have just said this is of this type without using the empty object S. Okay, so now it implements those functions from store, and then we use them like this, which is passing product store, and then ID, and then this is the ID. Yeah, ID, and then the new item is of type T. So it's of type T, to which T I'm guessing will be products, because it's taking name and price. Yeah. And then returns an array of type product. So it will return the okay. So we could also create a store for something entirely different. Say we have title, and then abilities is an array. So we have this. You should implement get save and list, and then we have this as theirs. So this is just a string, and then this is just an object of type that. So I would use this. We're passing the object itself, the ID, and something of type this, right? Yeah, the abilities, and then it would print an array of objects of type this. That means the object will have a title and an array. So it will be a title and the abilities array, one object, inside the array. Okay, your assignment. The infra team, it's supposed AI is building a shared job queue for internal systems model returning cache. Okay, nobody uses this, so it might be GPT'd. Nobody uses that. Okay, validation, moderation, sync, and more. Take a look at create queue function. It's been created for you. It takes in a new generic job queue data structure. I define a new job type. Okay, a new job queue type. There it is, with a method push that matches the implementation. Okay, that matches this implementation, and a method that matches the implementation. A method that implements this implementation. And export a new generic function. Run next function simply accepts a job queue and calls its next method and returns the results. Okay, it accepts a job queue, it accepts this type, and calls the next method. So okay, this has run next taking in this. taking in this function as input, is it? So first we're going to have an interface called job queue of generic type. So we're gonna do this, and then we're just gonna have a method push that takes in a job. Say job is okay, jobs.push. Okay, push takes in a job, and then we're pushing something of type T. So just gonna push something of type T, and then we're returning nothing, right? This method seems to just be pushing, and then we'll have the next method. What does the next method do? It takes in nothing and returns jobs.shift, so it will return T. Okay, and then we're expecting a function called run what's the function called run next that takes in something of type job queue. Job queue taking something of job queue and returns now queue dot push. Then we're gonna have to pass something in there. Okay, next, right? We have the next, takes in nothing and returns T. Okay. Okay, this method run next does what run next function simply accepts the job queue, returns its next, calls its next method, or it calls and returns the results. So it will be q dot. So here, how do we do? How do we pass it like that? Pass it like this? No, can't find T. How do we pass it? Oh, it's not a generic function, so it's a generic function. We'll do this, and then push takes in something, so that something is coming from where? So this is just returning the function. This function is taking in something. Okay, which method we're calling the push? What calls its next method? Its next method, yeah, which doesn't take in anything. So what is it in company? Okay, so there. Okay, that means this function will be returning something of type T or undefined still, right? Because it will be calling this method which returns something of type T. It will be inferred, man. It will be inferred, man. Like we might still need to do it. Okay, so I guess we're going to do inference, which is like my biggest fear. Generic type inference, you may have already noticed this, but in most contexts, TypeScript can infer type parameters by the actual parameter you pass in, so you don't need to specify them. Let's take our Titan transformer example. Okay, that's the thing that transforms types into like whatever. Okay, yeah, still remember, then there'll be a method, and then from transform we would say type, and then pass in the array and the method to take one element in the array and transform the type it needs, whatever. Okay, but in this case there's no need, because TypeScript knows that our humans variable it's an array of human objects, and the Titan transformer function takes a human and returns a string. Yeah, it takes a human and returns a string. So we can just call constating. Okay, yeah, there's no need to pass in this to be inferred. Yeah, that's true. Assignment, the feedback API, it supported AI returns multiple types of record, chat logs, feedback forms, moderation reports. They all include a text field, and we need a shared way to extract it. What? Okay, the feedback API supported returns multiple. What's the feedback? The feedback API supported returns multiple types, chat logs, feedback forms, moderation report. They all include a text field. Okay, and we need a shared way to extract it. You're given a transform function that accepts an array, and a transformation function. It returns an array of transformed values, so inputs, and then this is the function that takes in of type T and then returns some type that will be passed there, and then it's just an array. Then this array goes over and just pushes the thing that will be returned by the function and prints the array. Okay, complete the summarize feedback function. It should accept it should accept an array of objects that includes a text property. Okay, so we just have T extends or a string. Okay, accepts an array, okay, of objects that include that. Okay, property, use the transform function to extract the text values. Yeah, the text values are being okay. This will don't touch the code below this line. Okay, I guess we're passing in item of inputs. Okay, so it's an wait, why are we just passing in this item? This will be like one object, right? Don't we still need to do item.text? I don't know. Use the transform to extract the text values. Return an array of just transform text values. Don't pass type arguments to transform. Let TypeScript infer them. Include the string property. Use the transform function to extract the text value and return. Okay. Oh yeah. This summarized feedback will do the heavy lifting. Okay. We'll do the thing from taking only the text from the object. So let's just do infer.ts. Okay, this one will it's taking an array of object of type T. Yeah, we can do extends. I think last time we can do extend and then string. But like we don't do it like this. Okay, let's just have an interface. This is I'm just doing. I don't think it's even necessary. As text, and then we'll have text. Just doing it for typing, and then we can do it as text, right? Okay, so like it will show that this type, at least it is an object that has like the property text, and they are taking in an array of these objects of this type, and then we're just gonna okay, I think because this is only taking in one type, it's not doing the string. I think we're just gonna transform again here into an array that we're gonna pass in here of type type of strings, right? Let's see. I think that is what summarize feedback is taking an array of just strings. Okay, IDBL is an object. Yeah, expected. Okay. Yeah, but like transform is not taking in an array of objects, right? Let's see. It's taking in an array of strings, because like it's just passing in one string here and then returns it's taking in an object, maybe taking in another type and returns another type. But why is it not doing dot text here, right? Let's just see. Let's just have like if like it wasn't, because this is already returning, I would just we need to implement the method that we're going to pass in here. So that's what we will need to do. Okay, so we need to do const get text is equals to, this is taking in an item of type T, let's just say T, and then it's returning strings. So it will return it will return strings, right? Yeah, it should return strings from item, so it will be item dot text, right? And then we're just gonna return transform, because it is returning an array, and then we'll pass in our array. Let's see, pass in our data, our array data, and the get text. What happened? The get text method, right? Okay, this does. Okay, so like this will take in an object and returns a string. Yeah. Okay, so the method we need to call is summarize. Summarize this, and we do not need to do type. We don't need to do this here. That's what will be inferred. But if we were to do, we wouldn't do string first. We'll do it's of type what? The T is of type string, and then whatever. I know it will be inferred. We don't need to worry about that. Okay, so here we just pass in an array of objects. Let's just pass in 2. Okay, and then we'll see what gets returned. Might be an error. We never know. There it is. Okay, green. Yeah. Okay, it works. Oh, I was not confident at all in this. Okay, so that's our types. Okay. Like I was very, very confused because this is not doing dot text here, and then I forgot that like this method is implemented not here, it's implemented out somewhere. It's called get text here for now, and then it just takes in an object and returns a string. So even here it will take in an object, does this dot text inside, and then returns a string, which will be passed to this function, and then to this array, which will be pushed to the array, and then the array will be returned. Yeah. Okay, so that's type inference. They're just telling us we don't need to do human. But here, like what are the type? The type is an ID and text. So if we were to like pass in to infer, it would be the ID string, and the text or TypeScript will allow this, and text, I think string too, and that'll be the type, and then string. Okay, oh, it's an array of type this, so it'll be like, no, what? This is an array, right? Yeah, of type T. Okay, can we just do the arguments and the parameter? Okay, how about, oh yeah, we just say that text that is like a text that is like a that. Okay, oh, this is how you do it, I guess, but like back they won't do it like this. Yeah, so if we have like an object like this, because now we're not like okay, yeah, if like we created our objects outside, this is just for learning purpose, very useless what I'm doing right now. Okay, so if like we create our objects outside, and then we would do, okay, we would do const, let's just say human, as they did there. We'll do this and then this. Okay, yeah, it's an array of objects, right? Okay, but it has a type. Let me just see type human, and then there's a type of, like, this is the type, right? This would be the type. Yeah, this will be the type, and then these will be of type human, right? Let's see where we messed up. Okay, type, oh, for types we don't do, we use okay, see, this value is declared but never used. Yeah, that's true. So we'll pass in our human there. Human is not assignable to type parameter type. Okay, yeah, we so we'll do, it's an array of humans. So we're just missing a that. Yeah. So we'll do like this, and then when we go infer, we'd say this is an right? Yo, why is it giving us an error again? We'd infer it like this, man. What is going on here? Yeah, then string. Yeah, what's wrong? What's happening? Is it because like the type is declared down here and used up there? Let's just see. Let's see what's happening. See. Okay, that's not the issue. Okay, so that's that. Yeah, I think I tried. I don't know why this array is not of type. It's not okay. It's not a human of. Why? Okay, I guess it doesn't want to work. We don't know types as we thought we did, but it should work, right? Oh, yeah. What? Why doesn't it want to work? Somebody would leave a comment in the future why it didn't work, but by that time I would probably have figured it out. Oh, generic classes. Let's go. I'm extending today's video by doing useless things. Generic classes, we're kind of beating a dead horse at this point. Look, we get it. You can add type parameters to almost anything in TypeScript. Okay, yeah. So yeah, classes can be generic too. To keep it, someone is using this combine a few concept. In memory repository is a generic class. It implements a generic interface. Repository T, this will be a very good exercise. T is constrained to have an ID property. Okay, let's see. Where's the class in memory there? It's a generic class, of course. Extend something, we should have an ID of type string and implements an interface. That means this class will have all these methods defined inside it. There they are. It's returning in an array. Okay, sorry. And then we'll have this, and then that, which is returning nothing. This, which is just returning T or undefined. This an array of type T. Okay, there are a few things to note about the example above. The purpose of using the implement keywords to ensure that the class adheres to the interface. TypeScript will yell it as if our in-memory repository can't be used as a repository, while any old repository doesn't need an ID property. Our in-memory repository class does. An in-memory repository can be used to hold any type of object as long as it has an ID property. And all the implementation logic is shared between all the different possible types. Okay, so this will be an object. Okay, the instance of this class will be an object with what? With an ID. Okay, let's see how it will be used. So new, then the type is this interface. So okay, it will have an ID. Okay, when we save, okay, let's see, wait, ID. Yeah, the thing will have an ID. Save, then we're saving item by ID, I guess. What? No. Why did you pass? I think I saw we save for passing in an object of type T. Yeah. And then that object must have an ID. So if you pass an object when we're trying to save and it doesn't have an ID, I think we'll get yelled at. Of course, if we try to create an in-memory for something that doesn't have an ID, the proper an ID proper test would yell at us. Okay, yeah. Okay, light here guy. Okay, it's in a union of strings. Literal suppose does not satisfy the constraint. Yeah, it doesn't have like an ID or whatever. If you try to create a class with this type. Okay, assignment. Sapoya is launching launching experiments again. You've been asked to implement a class that manages feature flags by name. As support AI, we commit to features. Once a flag is enabled, there's no going back. Okay, what else? We have to implement a class that manages feature flags by name. Okay, you should have a string at least. Okay. Separately, we commit to features. Once a flag is enabled, there's no going back. Complete the feature flag function. You should keep track of all the enabled flags and allow users of the class to enable new flags and checks if the flag is enabled. So this is just a flag. Okay, a set of type T, a private flags set. The constructor, maybe that does what? Initialize the set? I don't know. Okay, enable. Okay, it's taking a type of string. Maybe check something and checks if it's enabled. If it's enabled, we're taking in the type T is enabled. We do something. Here we're just enabling. If it's enabled, we'll do something. Okay. Notice that in this the test suite, the extend string syntax allow user to pass in. It allows the user of the class to be more specific than just feature flags or strings. Let's check in the new flags. It's a dynamically considering the type of possible flags to a unions by using type parameter tips. This is in JavaScript. Okay, the add, yeah, and there's the checks. Okay. So what are we doing? It manages feature flags. Once the flag is enabled, there's no going back. Completely forget. You should keep track of all enabled flags and allow users of the class to enable new flag and check if the flag's enabled. So this will return true or false. This will just enable the flag. Or what is something that's being passed? Let's see. Okay, it's a union of strings. Yeah. Okay. Okay, so the interface should do what? The constructor should do what? Should add. Okay, I guess the constructor can just do flags that add. Okay, the constructor will take in something, right? Let's see. Yeah, there wasn't even a constructor. Yeah, this is just a type. So, but one method is taking in the type to save. Yeah, we're just gonna make it the constructor to save whatever the thing is. Okay, let's do this. Let's see. I'm just gonna see. So like can we keep this video under 30 minutes? Okay, no way. We're gonna keep the video under 30 minutes. It's already 8. And there's no way we're not gonna try to implement this. So okay, instead of having a class that takes in okay, we'll have this taking a string, and then we'll do flags, list of flags dot add, and then we'll add that string, and then we'll get an error. Okay, so you need to like okay, how to like flags, this dot flags is equal to an empty set. Is a set an array? Type never is missing. Yeah. Yo, I can't believe I forgot set. I was like what did we learn about sets, man? No interfaces, no intersections, I think. Yeah, objects. You see how to forgot about sets. Okay, so we initialize. Okay, this is a set. Okay, yeah, we can. Yeah. Like an array, whatever thing, and then do new set, and then pass in like this. But it's saying it's okay. So we need to do this dot flags. We need to do new, but it's already said. So it's this dot flags okay, equals to new. Nah, this doesn't feel right. And then we'll pass in an empty array. So this is unreasonable to flag of type T. Okay, T, right? Yeah, and then the argument of establishing okay. Then we'll have this of type T, do that, passing that, yeah, because yeah, we don't want to say string here because like that will be restricting our functions to its value. So how to what conditions are there to enable a flag? Okay, let's go back to generics. Okay, what conditions are we like using to like enable our fucking thing, our thing? It's starting to bore me now. Okay, it's starting. Okay, what is? Let's see. Okay, if it has value. Yeah. Okay. Enables. Okay, if it has flag. But okay, we're just enabling. Okay, yeah, well, they were initializing, and then we'll enable our thing here. our thing here, I guess. Flag, and then here we just return what does it mean for flag to be enabled? Is enabled. Okay, if return flag true false. Okay. Yeah, I don't know what I was doing there. I think I'm just gonna end today's video here. Thank you for watching, and I shall see you on the next one. He's gonna try a bunch of things here. So if we have this type and do let's just do object, and then feature flag, and then we're passing in the bg3 flag. See, yeah. Okay, we're expecting something in the constructor. Yeah, see, like I fucked it up, man. Yeah, so that would be that. I think we're done just this in this course. Okay, thank you for watching. So I'll revise and see what to do next. That's that. Thank you for watching. I'll see you on the next one.